This is to you, Eric. This is the answer to your question. The bad camera is going to be a little difficult, but you can easily do this yourself. Very easily, very simple stuff. You ask, why does water not stick to a spinning ball? That's what you said. Why does water not stick to a spinning ball? So here I have a ball, and it has water on it. Now watch this. Do it real hard. Water everywhere. It's spinning off of the ball. Spinning off of the ball. Dry paper towel. I'm going to pick a spot. Really dry. Pick a spot right here on the side. Boom. Very wet. You can see my finger right through it. There's the wet spot. Water does stick to a spinning ball. Stop saying that. Another ball. Tennis ball. Very smooth. Spin. Spin. Boom. Wet. Water sticks to a spinning ball. Why does it stick? Because of interactions between the ball and the water. In this case, chemical bond interactions. H2O bonds create water tension, all that. It's not gravity in this case, because this is so tiny. Gravity is next to nothing, but there are forces at work that keep the ball sticky. Now here's the thing. You think you're saying that water, that this is the earth. It's a plate. Now, I ask where your gravity comes from. What's the source of gravity? Because in my theory, it's this ball. So if the source is the ball, the thickest part, the most densest part would be at the center, so everything would be attracted to the center of the ball. So the forces at work right now are down there. So the water runs off this way. I can overcome that by spinning it with centripetal and centrifugal forces, forcing it out. But that's only because the big force, gravity, is down there. This is your earth. Gravity is the plate. So here's my question to you. And you go read YouTube. Listen, I just explained a very simple concept using a very simple thing. Why isn't there water sticking to the bottom of your plate? If this is the source, then there would be no gravity down here, right? This is your earth floating through space. There'd be no gravity out. Just like if this is my ball, there's no gravity down here pulling water. Do you understand that? This is my ball. The source of the gravity is in here, not down here, in here. So if the source of the gravity in here, then water wouldn't come off. Do you understand that? You're saying water should run off the bottom. But that's assuming that gravity is, if this is the earth, gravity's down there. Why do you assume gravity's down there? Just like if you have this plate, gravity is the source, the plate. There's nothing below it pulling the water down. So why does your water stay on top? What's the source of gravity? Why does your water stay on top? Why doesn't it float away? Okay, well, the plate's the source. Okay, then why isn't there water on the bottom? Water would stick here. There's nothing pulling any water down here. Still didn't explain why water's here. Okay, it's sticking to the plate. Water's down. None of that. But you could easily prove that to me. Because if the United States is over here on your flat map and not in the very center, if it's over here, then gravity would be this way, right? Because this is the thickest part of the plate. This is the densest, most plate right here in the center. Out here, things would press inwards, and things would stick like this. If the center, if there's no gravity down here, no gravity here, things would stick on the edge. Right? Correct? I don't know because you don't know, because you don't know your theory. But you just asked, why does water not stick to a ball? It does. Go try it. I just proved it to you. If you don't believe me, go try it. I'm a lawyer. I'm not a scientist. I'm not a NASA shill. I'm a lawyer. Go try it. And then think about that if gravity's not down here, and this is the earth, my sphere is the earth, and there's nothing down here pulling the gravity, then why would water run down there? You're saying water should run off, but why? If in the middle is the source of the gravity, if the ball is the source of the forces. Here, that's why water's sticking. It's because the ball is a source of forces with the water. It has bonds with the water. So that's my answer to your question. I've asked you a couple of questions. Why doesn't water on the bottom? Why doesn't it pool in the middle where the most is? Why aren't things stick to the edge? Why can't we just walk around the edge? And why doesn't on the edges, why doesn't gravity go this way? Because this is thicker. That's just a simple question. The reason gravity, the thickest is in the middle, see? So things want to stick to it. And it's not strong enough that when you jump up, now you're like, well, that's just a little bit of water. One more thing. You're saying that's just a tiny, tiny, tiny bit of water. Africa is 5,000 miles long. The deepest lake is 1 mile. It's 1/5,000th. 1/5,000th. So a lake would definitely stick to the edge of the earth. This is definitely, the water is definitely 1/5,000th the size of this. But it's because of gravity. Do you understand? Gravity is the answer. And the gravity comes from the ball, not from somewhere here. According to you, gravity comes from the plate, right? So things should stick to the plate this way because there's nothing down there, right? That's the same reason. My ball is still soaking wet. Still soaking wet. Why? There's still water sticking to it. According to you, it shouldn't be there. But there is because of the forces at work. It's not gravity in this case. Gravity is a much stronger force, which is why when you go in the air, you're still stuck to that place on Earth. Because kind of like a magnet, it sticks you there. If you move the magnet, it moves with you. Right? That answers your question. Have a good one. Love and peace. I just hope this helped you. Just trying to help you, educate you from a guy who's not a NASA shill. Thanks.